Hello friends, सबको नमस्ते. So today in this video we will create an animal detection code. Okay, for that we use YOLO model. So let's get started. Before explaining this code, please like, share, and subscribe my channel. So let's get started. So we first download this Roboflow library, which can help us to download dataset from the Roboflow. Then we have to run this file, run this cell, sorry, so that we can get the data set, animal data set. So wait for the seconds. So let me show you. So this is a data set animal 2. Okay, first of all I will change the name from animal 2 to animal detection data set. Okay, so let me run this cell, and for that we use os.rename it. Name will be changed. You can see that it contains test, train, and valid, and you can see data.yml file, which give us detail how many classes we have. We have 10 classes. Okay, and this is your test, train, and valid data set. Let me show you the train. In train you have images and labels. So let me, and one more thing, that when we will go to labels and when I will click on first txt file, which give us detail how the data set looks like for you. Let me show you. So there's a data set, and you can see this is, you can say this is a class, you can say this is. And one more thing I want to tell you, that in when you will download dataset in a YOLO v8 format, your first will be this is a x center, this will be your x center, this will be your y center, this will be your width, sorry, this will be your width. Okay, this will be your width, and this will be your height. In this format you will get the data set when you will download the data set from Roboflow in YOLO v8 format. Okay, so how we can retrieve x1 y1, I will explain you, y x2 y2. Okay, so don't confuse. So let's get started. So this is a, you can say this is a draw about, you can say the bounding box function, draw bounding box function, in which we get a parameter image, then the box labels, and then label, then a color sample. What is a color sample? Color sample is basically a list of the colors from which we select one color. Okay, so first we make the copy of that image, then we expand, you can say we expand that box which contains some values, and that we can expand them into int format. Okay, x min, y min, x max, y max, and randomly select one color, then we plot the rectangle. Okay, so we do rectangle image with boxes, x min, y min, top left corners of the bounding box, bottom right corner of bounding box, then the color, this is your thickness. Then we have to put the text. So how we can put the text? I want to put the text on image with white color. You can say I want to put the text with you can say black color. It is not a bright color. Okay, this is black color. So image, we pass the image, then the label we want to display, and here I am just showing x min plus 2 and y min plus 15, means I want to display down, means in the inside the box or top left corner inside the bounding box I want to display that label. So this way we can display it. And then this is your you can say this is your scale, this is your color, this is your thickness, and this is your line A4. Okay, so let me run the cell. This way the draw boxes will get ready, and now we have to, okay, now we have to visualize the images. So how we can do it? So this is your images, this is your label directory. Okay, we want to print how many labels and how many you can say images are present in train and images directory. So this is your answer, 700 and 700, means 700 images are there. Okay, and labels and images, and these are the classes we have: cat, kitchen, cow, dog, fox, goat, horse, person, raccoon, skunk. Okay, skun. Okay, then these are the color sample I have already do. This is a color which from I have selected, which I can randomly select one color and draw the bounding box. Okay, now after train directory we get a list of the text images. Sorry, this is not a test images. Okay, let me is it os.list train images file, means it will give me the name of all the images present in a particular directory. It means in train directory. Okay, now after that I want to plot 16 images. For that I have used 4 rows, 4 columns. Figure size will be 16 for 16, and for plotting we use plot.subplots. Here figure basically represent the entire subplot. Axis here in this line it is in a 2D format, and here axis.label it converted to 1D format, which is easy for iteration. Okay, So as we want to plot 16 images, so we have to loop 16 times. That's why for IDEX in 16, it will randomly select one image name from the image files which we have created here. You can say list directory, and after that we have to create the path. How we can create a path? Just use os.path.join, then tell train directory and this image name which we have selected randomly. After that, I want to know the label path. How we can know that? One more thing I want to tell you that see here images. Let me go this way. See here images is in a jpg format. Okay, now labels is in a txt format with the name of the image. So how we can retrieve that? How we can know that? Okay, how we can retrieve that? For that we can easily do that. This is, you can say, last three character we can minus last three character. We do not read jpg, just other thing will remain same, but last three character will be not be read. In place of that we use txt. Dot will be there, but txt will be there. Okay, so this way we can get a label name. After getting the label name, we get a label path, os dot path dot join train label, then a label name. After that we read image. Okay, read image, then we convert the image into from bgr to rgb. Now how we can retrieve x1 y1 x2 y2? This is our main thing. Okay, so here it is, the whole thing. We with open label path, when we open the label path, with the label path is in a text format, so we can open it in here. And r means in a read mode we want to read. As f means all the content is represented by the f here inside that particular direct in txt file. Then for line in f, mean line by line we'll read it. After that we retrieve. You can see here line dot strip dot strip will give me all data in a list format. Okay, line dot strip dot strip give me data in a list, you can say list format in a okay. After that we will first I know that you can see for explanation purpose. Oh sorry, where is content? Where is content? See here, content, enable data set, and you can say train labels. Okay, so here you can see this first character is your first character will be, you can say first character will be your class id. So how we can get it? Just use int data dot zero, because I already get data in a string format. Let me print it here, print data, and I just want to break it. Sorry, I don't want to, I want to break it here because I want to display just one image. Okay, so let me run it so that I can show you what is happening here. See here data, okay, line by line. When I will talking, when I talk, so okay, yes, okay, I have to break it here also. Just for one iteration I will show you. Okay, so see, okay, so this way I get a list here. Zero, all thing is in a character format. Okay, first thing is a class id. This is just x center, y center, width and height. So this way a class id I will get. After getting the class id, how we can get a label? Just use this class names and just pass the class id, you will get a label. And this is your x center. Okay, in a float we wanted it. Initially we wanted in a float way. Why? Because you can say this is not in a normalized format, so we have to normalize them. How we can do that? Just use float way. You can get the width and height this way. After getting the width and height, we have to get the image height and width, and we want to get the x1 will be like this, x center minus width. Okay, first thing will be happen this, we will divide width into 2. This is your first step. After dividing the width into 2, we will subtract that with the x center. After that we will multiply this whole thing, we will multiply with image width. We get normalized x1 y1. Okay, now this way, same way for the y1 and same way for, we multiply x for the image width, and for the y we multiply with the image height. Okay, this way we normalize them. So let me show you, let me print x1 y1 also, so this way. Okay, so let me explain you what is happening here. See, after multiplying it, I get a retail 0.054 90 154. Okay, this way I get the coordinates value x1 y1 x2 y2. Okay, So this way, this is happening here. Now, after getting this x1, y1, x2, y2, and y1, y2, okay, we just use, we will zip that, or you can say, okay, I make a list of that, make a list and contain an x1, xy, xy box, and we just give it to draw boxes. This way, I will get the image with bounding boxes over it. Okay, so let me close it now. Now, see, okay, now then we have to show images and access will be off. Yes, plot will be tied layout and plot dot show. Now let me run this. We will get the images with labels. I think so I have print. I have not comment this print statement. So let me print it again and let me run it again. Okay, let me run it again. Now it's okay. Okay, see, Scott, dog, cat, dog. You can say the thickness is large, so you can decrease the thickness. Let me decrease the thickness of the text. It's 2. Let me put it 1.5. Okay, now let me run it again and let me run it again here. Okay, what's the problem? Argument thickness is required to be, oh, thickness required to be an integer. I put it in a float way, so it will be 1. Now let me run it again and let me run it again now. Okay, so it's good. Dog, person, raccoon, goat, dog, horse. Okay, it's working very well. Okay, now we have to load a YOLO model, pattern model. For that, we use Ultralytics. Okay, we install the Ultralytics. Then the model which we are using is YOLO10 L.pt. Okay, it's just better accuracy. No, just erase it. It's not. We use YOLO10 L model for. Okay, and we train it on a custom data set. Just give your data.yml file path here, epoch 20, but right now I just want to do for a 10 epoch. Okay, okay, it will be better to for 20 epoch. Image size will be 640. Batch 8 means when the entire image divided, it should be in a 8 in each batch. 6, you can say 8 images will be there. And this is your folder name. What's the meaning of this? When you will run this cell, you will get a run folder. Inside the run folder, automatically created a run folder. And inside the run folder, detect folder will be there. Inside a detect folder, you will get a one folder whose name is decided by us, and this is that name. And inside this, you will get the wait folder, and inside the wait folder, you will get the wait file which we can download it. Save true. Yes, we want to we want to save a wait file. Save period -1 means we do not want to save every epoch wait file. And you can say patience 20 means early stopping, means after every 20 epoch it will see that there is any changes, or you can say changes in accuracy or in a loss. It will stop the training, and we can get the best wait file. Validation true. Yes, you want to validate it. And you can see we are annotating, means not annotating, we are data augmentation is doing here, because it might be possible because we have a 700 images but the classes are large. So it might possible that for the single class, the number of images will be less, so we need that augmentation so that we can increase the number of images and increase the accuracy. Okay, so for that we use random rotation, random translation, random scale, random share, person, vertical flip, horizontal flip. This way we can add a data augmentation. Now let me run this cell. It might take time, so wait for it. So our training gets started. Okay. So here it is. In first epoch, you can say we have bounding box loss, classification loss, DFL loss. DFL loss is, you can say, distribution focal loss. Okay. Now how we can plot the graphs? So for that we have to go to the run, where it is. I think so. I have to open the content folder again. You can say we have a run. Okay, inside run you will get a detect folder. Inside a detect folder you will get enable detection. Inside the and will get this result.csv file. Basically this file, csv file, contain all the losses data. So how we can retrieve that? So first of all, you will get you have to know the result path. Inside this you can say detect animal, YOLO10, and result CSV. Okay, after that we have to make a data frame. For that we use pandas pd.read CSV. It will create a data frame. Now we have to create the columns name. So for that we use df.column.str.strip. We will get the df.columns. We clean the columns. Now we have to plot it. For plotation we use figure 8 10.16. Figure size will be there. Now to plot the you can say bounding box loss. For that we used we have to get this thing, training from train df box loss, and for classification loss this one, and for the dfl loss this one. And title will be training losses versus epochs. This is a x label, y label, legends, yes, grade true, and show yes. Okay, so this way we do it. Now let me run this, but we cannot run it right now because our training is going on. So now let me run it. Okay, after 20 epoch it will show me what is the result. After that 20 epoch completed, we have to load the model. So how we can load the model which is trained on a custom data set? For that we use this one. Just give your path of your best model. It will load your model which is trained on a custom data set. After that we use test image directory. This is your test image directories. Okay, you can see it. This is test and this is images. Okay, now this is, I already told you what is this happening here. This is make the list of all the images present in a particular directory, means images. After that we will randomly select one image. This is flotation, I already explained you. Randomly select one image. This will be grad image path. We will open it, just pass it to the image, means the model. And to retrieve the, as we passing on a single image to retrieve the result, we use zero index value here. Yes, image will be np array because we are reading the image into pill format, so we have to convert it into np array to perform the drawing draw boxes up over it. Okay, for that now we have to result the boxes. We iterate over the boxes. Okay, if confidence is greater than 0.8 it might be possible, but let me close it. If we want to add some condition here, you can easily add it. You can, how we can do that, just wait, let me show you how we can do that. So friend, this way we retrieve the, you can say box.conf zero index value, give me the confidence. If the confidence is greater than 0.8, then only we draw the bounding box. How we can get that bounding box? Use the box.x by expect zero index value. You will get the box and all values should be converted into int format. Then we have to use x by x by, all values will go to x by variable. How we can get a class id? Just use box.class 0. You will get a class id for label. Model name class id will get a label, and just pass it to the draw boxes function. It will give you the image, then you have to show it. Access will be off and flotation, and this way everything will be done. Now let me run this, and your training gets completed. For 20 epoch it will show all thing. It reaches to 11 epoch. Okay, it will take time, so let me come back when your training gets completed. Wait for it. So our training gets completed, so let me show you. So our training gets completed. See, now let me show you the graph. So this is the graph which we have: box loss, classification, and dfl loss. Okay, for 20 epoch, as they are decreasing, so it's good. Now let me show you the result of the model which is 20 epoch. See, no detection is there because we have applied the condition. Because if confidence is greater than 0.8, or you can say the 80%, then only we have to draw the bounding box. It might be possible that your model, or you can say the R model, is not reached to 80% confidence. So how we can do that? We can increase the epochs value to from 20 to 50, and you can see the better result. But right now for getting the result we have to use 0.5, but I think so 0.5 also it will not show. And also one condition, one thing is also there, that we have only a 700 images, and we have number of classes is I think so more than near to 10 we have number of classes. So for that I think so for each class we have 100 images. So I think so number of images, that's why it's not classifying, or you can say detection is not done properly. So for that, so we have to increase the epochs value also, and we have also increased the data augmentation value also, things also. In 0.5 also it's not working, so let me show you it. When it will work, it have to work on 0.0, means draw bounding boxes with less greater than 0.0 confidence. So it shows some detections. You can say goat, dog, it's a cat, not a dog. Okay, some shrunk, skun, sorry, and this is, you can say, raccoon. This is fox shrunk. I think so. This is fox. This is chicken, not a dog. Okay, this is fog god. So this way you can increase your, you can say, when you will increase your epoch value to from 50 to 50, and also increase the data augmentation, then and then you, when you will apply this zero point 0.8 condition, means the confidence when you will increase to 80%, it will show the detection. Okay, so this way you can do it. So please, I've explained each and everything how you can do that. I've explained each and everything line. So please like, share, and subscribe my channel. Thanks to all.